It's almost cheaper for me to replace the device than it is for you to take it down, send it to a test lab, I recertify and say, yep, this is good for another 10 years. Just replace the device. So now I start looking at, as a manufacturer, give you a little peek under the covers or inside baseball, if you will. Do I put in all the technology that I need or I want to into a smoke detector that I sell in Europe as opposed to one I sell everywhere else in the world?
This is episode 93 of the Fire Protection Podcast, powered by Inspect Point. Want to welcome Dr. Roger Reiswig from Johnson Controls onto the podcast today. I've met Roger a few times at some NFPA conferences and some technical committees. We sit on at least one together. I don't know if he's on NFPA 25 or not. Probably should check my sources, but yeah, it was great. You know, Roger's more on the fire alarm side of JCI and all that. He is an industry liaison for them, kind of what Terry Victor was back in the day, and more on the fire alarm side of things. And it was great. He has a lot of knowledge of the history of the NFPA codes and where NFPA 72 has evolved to, and just what Johnson Controls is doing with their products, and just the industry is doing with their products. So it was really cool. I learned a lot from it. And, you know, I would love to have him on again here soon to talk about some of the kind of the stuff coming in the future. So want to welcome Roger on the podcast, and hope you enjoy. Thanks again. Roger, thanks for joining here.
Drew, I'm really honored that you had me come on. So thank you.
I forgot when I first met you. I met you a few times, but it was probably at an NFPA or some event. I stopped by the booth and somebody introduced me to you. So now we get to chat for a half hour.
That's great. That's great. Now, I see you on the various committees, and we were, whether we're doing remote now, some of them, or we can do them in person, that we're working on. And so it's good. It's good to get together and just have a one-on-one for a little bit.
Yeah, it is. And the face-to-face does help, I think, with some of those NFPA and other code committees. But I think if you do go that hybrid route, you get you have more active participation. And you brought up to me, like, you get more global presence too, right? Because now more people can make them.
Yeah, there are several committees that I'm on that I'm starting to see more international people participate because they can do it remotely. You don't have to be in person anymore. So and it does help to get more of a global representation audience. NFPA, UL products. It's not a US thing, a USA thing. It's a global thing because the same code standards products that we use in the Mideast. We use through Central, South America. We use in Northern Africa. And they're using the same NFPA 72, NFPA 101, UL 864 fire alarm. It's all the same.
Interesting. So those nations, yeah.
Yeah.
So those nations
for them to
adopt
involved and put their perspective of what their countries want. Really, I think helps to better the industry, going forward.
Yeah. Yeah. So those nations adopt, obviously, the NFPA standards. Are they on like latest and greatest, or are they going pretty, like, how often do they revise?
So they're very aggressive. They'll use the ICC, the International Building Code. They'll modify it to become their country code, like the international, the IBC, Indian Building Code, India. They take parts of NFPA 101, they take parts of the IBC, and then create the India Building Code that's used all across the country. Unlike the U.S., we don't have a national building code. We're kind of unique in that as you look at other countries. But they're very aggressive. If the 2025 edition of 72 came out, they're looking at it, looking for changes that they should implement, and it's adopted pretty quickly. It's not like the U.S. states where some take several cycles before they'll adopt to a later edition. They want the latest and greatest. And a lot of people, they understand it, that a lot of technology goes into it. Code work, research work goes into what's being changed. And then to add that to a newer code. And not to make it political, but I don't think there's as much politics and legal lawyers that get involved when you get outside of the U.S. the way we do inside the U.S. and politics hits, and that's a whole nother discussion. But they're pretty aggressive in it.
So I may dig into that a little bit. So I recorded another podcast earlier today, and we were talking about, and it was a NFPA 25 and even 13 thing for sprinkler, and I was just discussing, New York City. They're still on 2014 edition of 25, and then the states on 17. So it makes it just complicated. And honestly, that's what gives us a business, right? Is the complication of it. But why? What? I mean, it's probably more than anybody. Why is it really politics and lawyers that slow it down in the states for going to more recent codes?
Yeah. So now you're going to get me in trouble. So a lot of states, municipalities it's the money that comes into it, because now I have to, and really the argument might not be as relevant today as it was, let's say 10 years ago,
sure,
with the advent of NFPA link. But now for me to say as a state or a city to say, okay, now I have to go out and buy this edition of whatever document it is for all my people. And I have to educate my people on what all the changes are. And it takes time and it takes money. And I can see that to a point. I mean, we have the same problem, right? If I'm at Johnson Controls and I have my own Simplex technicians and I want them to go out and perform a service to a fire alarm system, well, what edition? What edition is that state using? When a state adopts a new edition, I got to bring my people back in, educate them on what the changes are. But that's kind of the cost of doing business, whether you're in the automotive field, the health field, whatever it is. And at the end of the day, you and I both do a lot of work on the codes. We all try to raise the bar. We try to make things better. We're not out there trying, just to sell a widget or to sell a service. We look at what is research doing? What are maybe some events that have occurred recently that we need to help mitigate any issues that have gone on, and then to make that code better. And ironically, California is one of the states that adopts stuff very, very quickly. When new codes come out, they're a very early adopter. Even before the federal government, oftentimes California will take it on. So hats off to them.
Yeah, hats off to them. I mean, they're slow on some parts of the industry, which I've commented on before, and mainly on the sprinkler and suppression side. I think the alarm side they're definitely ahead, but on sprinkler, they're way behind too. So it's anyway. I don't want to get caught up on this, but so you mentioned Johnson Controls. I just want to introduce you to the audience. Where did you get your start? Where have you been in your career, I guess?
No, sure. Well, I started with Johnson Controls, actually Simplex time recorder company, back in 1986. This is my 39th year. This fall will be 40 years with the company. So I started as a Simplex time recorder, and then we dropped the time recorder, went to Simplex, and then Tyco bought us, and we were Simplex Grinnell. And then Johnson Controls and Tyco merged a few years ago, and Johnson Controls is now the premier name. And Simplex is one of many products that JCI sells in the industry. So I started off as a technician while I was going for my electronics degree. My dad's best friend in the Marines was a service manager in Baltimore for Simplex, and he saw the work that I was doing in my electronics and offered me a job. So I did that, did installations, inspections, a lot of programming, and then went into field engineering, and then product support. Went into management. I worked in the Orlando office for a while and ran that office. And then for anybody out there that might remember Bruce Frazier, he was our industry relations person at Johnson Control or Simplex at the time, and he retired, and I took over for him. So I kind of view myself as the liaison between the company and the industry, right? Whether it's NFPA, iCodes, UL, FM, Intertech, ETL. A lot of the trade associations, University of Maryland, Polytech, and the others, WPI, that are out there. So I spend a lot of my time outside of the company working on things. And I also work globally. I'm on the European Alarm Association. It's called Euralarm. So I do a lot of work with them. And they have multiple sections. They have a fire section, a service section, security section, extinguisher section, and I do the horizontal compliance committee. I'm the chair of that committee. And horizontal compliance is something that affects all aspects of the industry. Some new regulation or battery requirements or what have you. So I work a lot with them in the EN side, European listing side.
How does the European? So you're on that. You chair that committee, and you're on that council or that industry kind of organization. Is the EU fragmented on different nations, or are they pretty? Or do they adopt their own? Or I've always wondered that. I know the UK is kind of on their own thing, but I don't. The rest of continental Europe, I've always wondered that.
Yeah, the UK has the British standards that they utilize, and then the European Union has the EN standards that they predominantly use. But it is interesting that, because I kind of thought the same thing. Okay, we got the EN standards. Everybody in Europe uses this. And now as I become more intimate with them, it's like, well, yeah, but when you're in Germany, you do this. And when you're in France, they require this. And when you're in Italy, they require this. And it's like, oh, okay. It's almost like the Unified Facilities Criteria, the UFC. Everything's housed together. But if you're in the Navy, do this. The Marines do this. The Army do this. And so it is interesting how they do that. So no, they are fragmented. They are not all together on what they do. A lot of the general stuff, yes, but then it gets into some testing aspects, frequencies, replacement of devices. They need to occur. For example, in Europe, there's a requirement to replace smoke detectors every so many years, and that varies depending upon which country you're in. And it's like, well, yeah, they can be cleaned or maintained, or like, nope, you can either recertify them, send them to a manufacturer or to a company that does that, or you replace the devices. In the UL NFPA world, as long as the device is in proper sensitivity range and tests properly, functional tests, it can remain in service for forever.
Yeah,
so it's those kind of things that are a little bit different.
Yeah, that's interesting. It is a pretty significant change because. You see that on the suppression side a little bit, but you don't see that on the fire alarm side and the detection side where you're having to replace automatically.
It's interesting though with the manufacturer, because I work under the manufacturing arm of the company. So now if I have to replace a device, because let's face it, it's almost cheaper for me to replace the device than it is for you to take it down, send it to a test lab, I recertify and say, yep, this is good for another 10 years, just replace the device. So now I start looking at, as a manufacturer, give you a little peek under the covers or inside baseball, if you will. Do I put in all the technology that I need or I want to into a smoke detector that I sell in Europe as opposed to one I sell everywhere else in the world? For example, in a UL system, the device can tell you what the sensitivity range is, how hot it is, the carbon monoxide settings, and it can even do automated testing of certain things. Well, if I got to replace the device every 5 years, 7 years, 10 years, depending upon what country I'm in, is it worth me doing all of that just to throw it away and replace it with something else in 5, 7, or 10 years, depending upon the country? So it's those kind of things that you kind of got to wrestle with when you're going out into the market, because everybody's very price conscious and they also want technology, but there's got to be a happy medium. And typically an EN device is a little bit cheaper for me to manufacture and to sell in the marketplace. It's true for everybody. It's not just Johnson Controls than it is for a UL product.
Interesting. Because of testing is it because of the testing protocol? Or
some of the testing protocol, some of it's kind of the same too that we utilize. But it's more for the functionalities of the features that are required or that people are demanding or looking for. Some of the smoke tests are identical. So not to get too far off on the subject, but we've gone from NFPA 72 from not telling you how high a smoke detector can be to telling you that you can now go to 40 feet. And NFPA's Research Foundation, for those that don't know, the Fire Protection Research Foundation, it's a wing under NFPA, separate entity that was giving grant money. And they didn't do any actual research. They did paper review research of multiple tests that other people have done Many of them came out of Europe. And in Europe, they determined that you could take a smoke detector up to 40 feet or whatever that comes to in the meters.
Right.
And based on that research, they came back to the NFPA 72 document and said, we're now going to say you can go to 40 feet for your smoke detectors for placement. Up until now, we've had nothing in 72 that told you how high you could go. So you had to go to you were supposed to go to the back of the book to the SFPE annex that was the performance-based design for automatic detectors and figure out what kind of kilowatt of fire do you have, the size of the fire you anticipate, the air exchanges that you might have, and then run some kind of a simulator. And then that's how high you can go with the detector and how far apart they can be spaced. Nobody ever did that.
No, right.
So, but this is an example of where Europe has kind of helped us with the NFPA world to make standards better.
Where does it make sense? This is just my service and inspection and testing side. At some point, how are you gonna test that at 40 feet without it being remote testing? Right? Are you really getting a pole up there 40 feet? Probably not. So there's got to be a certain point where that makes sense.
Yeah, that's an interesting aspect because we do say in 72 that if you can't maintain or test a device after it's installed, you do not install it. Not meaning that you just say, well, I can't put it there, so I may as well not put anything and move on. If you can't reach it, then there's a different way to do it. Do you use beam detectors? Do you use a UV IR? Do you use a video image detection? Something else, rather than in the old days where somebody would take an Embassy Suites, go to a 10-story atrium, put a smoke detector at the very top of the atrium while the scaffolding and everything's all in the building. And then now it's all gone and you got to hire Spider-Man to get up there to test the device. So 72 said no more. If I can't service it, you do not install it. You do something different. So it's a good question. If I have a 40-foot ceiling, am I able to reach it? And if not, then there's a different way you need to protect that area.
And does it say service obviously you guys have some of the nice remote inspection technology. You'd have to service it. So servicing it means getting somebody up there. So that it's kind of two different things. Yeah.
Well, and that's a good point too, right? Because let's say you put like a horn up there, and we have devices that can test themselves. The horn turns on. I have a transducer inside the sounder, and I can hear that, make sure it's at the right audible level, and then if it passes, it sends a signal back to the control unit. And all that's great, and I can do a visual inspection, of the device. But when it comes time to replace it, are you able to service it? So yeah, routine inspections as opposed to servicing or having to replace the device is an interesting aspect. Same with visuals too. If I have a visual strobe or smoke detector, am I able to clean it, maintain it?
What is the overall? I know remote testing is still, and we said on the standard together, 915. And I know it's been brought into the other different standards like 72 and 25 and 13. But how has the adoption been there? Overall for some of the remote testing technology.
Well, so I thought you were going to say the adoption of the standard, because I haven't seen a whole lot of places adopt the standard or ask for it.
Yeah, right.
Yeah, and that's a whole other discussion too, right? Yeah. About adopting latest standards and codes and when things have just been developed. But I think the adoption of the technology is starting to gain acceptance.
Yeah.
For me to be able to do things like a remote inspection of a horn strobes. I mean, think about that. 20 years ago, 30 years ago, when I was in the field and you had 500 horn strobes, I would need to tell the customer, hey, I'm going to go ahead and turn on the horns. I'm going to run around the building as fast as I can, mark them all off, that they all were loud enough and the flashers all flashed. And it's probably going to take me maybe 20 minutes or a half an hour. Well, some facilities say, no, you can't do that, or you can do it on a weekend when nobody's here, or if you're in a hospital, you can never do it, or a prison or something like that. So the development, as an example, for remote inspection of horn strobes, where we have a visual photo cell inside the strobe that can tell you if the strobe actually flashed, or a transducer, also works with speakers as well, to be able to say, can you give me maybe 5 to 8 seconds. And I'm going to turn on every device and I'm going to tell you if they all worked and if one didn't work, which one it was and it failed and where it was. And customers are like, yeah, you can do that. I turn it on, everything goes off. That remote inspection, people are very receptive to. Like, that's a great thing. In the sprinkler world, you're starting to see manufacturers come out with devices that can flow water around the water flow switch.
Yep.
And as that pump turns on and it's running water past the water flow switch, the fire alarm is programmed to know this is a test mode. Don't go into alarm or evacuate the building and call the fire department. People are accepting that.
Yeah.
And there's other ways that people are coming out with to test water flow switches. People are absolutely accepting these. The challenge has been, and I don't want to say a challenge in a bad way, but a challenge in a good way is Underwriter's Laboratory. Because now, if you're a customer or an engineer, you should be asking the question, that's great that you can do that remote test. Is it listed? Has somebody verified that this is going to do what it needs to do? Does it meet the intent of the testing that's shown in NFPA 25 or 72 or NFPA 10? And at first, we as manufacturer, I had to go to a third-party entity because there was no listing for me to obtain. So, for example, I went to University of Maryland. I worked with the fire protection engineering program, and they did some testing for us and then wrote us some test reports on how the devices functioned. And then UL did something that they call a verification mark, where they'll take a way to verify a performance characteristic that you have, that it functions properly. All of that, fast forward to today, all of that now is starting to be adopted or not adopted, added into the UL standards. So now you're starting to see in the various documents abilities to test for remote inspection or automated inspection, as it's being called. So it's taken us a little bit to get there. And UL, not to hijack the conversation, but UL and NFPA, they work together, and one doesn't necessarily drive the other. Sometimes they do. And this was an example. NFPA 72 came out, and so did 25 and a few others, saying an automated inspection could be done. Well, UL looked at it and said, we don't have a test for that. We got to start changing things. UL changed things for 268 for smoke detectors and how we detect smoke, and then that pushed it into 72. Low frequency sounders, 72 did that first based on research that was done from the Research Foundation. And then that took UL to create a standard on how to test for low frequency sounders. So that's why you see a lot of the UL people, the Intertech ETL, FM Global people around all of our committees, because it's kind of both ways. UL, Intertech, all of them tell NFPA, we're going to start to test differently. But then they're also listening for, what are you doing differently that I now need to test for in my products? And that's kind of how they both go together. So I think it's a pretty good relationship on how that's being done.
Yeah, I was actually in one of the 25 meetings early on. I was a guest, but it was like right when we started the company, and UL was in there, and all the 25 committee meetings were there, and it was like, oh, we don't have a standard for this in UL. And then NFPA, the committee's like, well, we need to have a standard before we put it into so there's like this chicken or egg thing. And they got it done, but it was just like, oh man, and they worked it out, and it was faster than I expected. So, and I think it came out in the next edition. Where
mass notification was like that.
Oh, really?
When MLS came into NFPA 72, there was no standard for a mass notification system. So what we did on the committee was Chapter 24 in 72 of 2010. We actually said fire alarm UL 864 listing needed to be done. And then UL went and created UL 2572 for mass notification. Then for a few cycles, we said 864 or 2572. And then last cycle, I think we finally said everything else drops away. It's got to be UL 2572 for mass notification, which everybody has. It's out in the marketplace, and it's not that hard to get. But it just to show how it kind of flows back and forth between the two. Yeah,
it's interesting. When we were talking a few weeks back, you were mentioning, and I didn't know the history of this, but like prior to 2010, I think it was, NFPA 72 is a little bit different, and how they kind of wrangled everything together?
I think we put on the Wayback Machine, Mr. Peabody, and if you remember that. But,
Oh, yeah.
So prior to 2010, the scope of NFPA 72 required you to test the smoke detector, verify the relay turned on, and then verify the doors closed, verified elevator recall worked, verified fans turned on, turned off. And the Standards Council was kind of looking at that and said, you people in 72 world are going outside of your scope. Your scope really ends at the relay. Your DMARC is the relay. You shouldn't be telling people to go out and test elevator recall and all the rest of this stuff. That's up to other standards to do that. NFPA 80 for fans or for doors and dampers and what have you. So that's, I think, one of the few times you see a standard pull back and say, we are going to lessen what you need to do on an inspection. So now it says you check the smoke, you check the functionality, you verify the relay turned on and off. That's the end of your job. It's somebody else's job to verify after that relay. That was also the introduction for NFPA 3 for commissioning, because they said, fine, where is that document then that I can point to that tells me to test everything from end to end? And NFPA said, well, they had a guide for several years on how to do that commissioning, but then they created NFPA 3. And what happened with NFPA 3 was the world didn't really want the whole commissioning document. They wanted the chapters for integrated testing. So what the Standards Council did is they said, let's pull out the integrated testing parts. Let's make NFPA 4. And that's really what people have gone after, is saying, okay, now we're going to bring together the elevator people, the fire alarm people, the HVAC people, and say, you blow smoke in the smoke detector, you verify the relay works, you verify elevator recall work, you verify HVAC worked, and that's integrated testing. Everybody's there together. But there's none of this. Well, my relay worked. Well, I can short the relay contacts and my stuff works. Well, there is none of that when you do an integrated testing part, because you corral the cats together.
Now, the one thing, NFPA, 3 and 4 are still relatively new. Am I correct? It's like, 10 years old, right? The problem with that, they're great documents. And I remember, talking to Terry Victor and all that when they were coming out, and we might have even talked about it on the podcast. And it's just the adoption of it. Like, and this is what you mentioned before, is like, HJs haven't adopted NFPA, or they don't even, I'm sure they know about it, but it's like the adoption of it's a little slower. So yeah, that was created 10 years ago and great, but like, man, it just takes forever.
So about 2 cycles ago, in both 101, 1, and IBC, there's now a requirement, and it's kind of embedded in there. Not a lot of people have realized it yet. When 2 or more systems are integrated, you shall perform an NFPA 4 integrated test. So it's new. And again, states don't adopt codes as soon as they come out. Codes tell us when to do something. Standards tell us how to do it. And I know it's the later edition of the I codes in 101, and states just aren't there yet, but it's coming. We're in a process. And the states that have adopted it, it's amazing how many AHJs engineers are like, that's in there? I didn't realize that was there. Well, and then even us installer maintainers, whether you're a dealer or a direct office. Now, if you're signing up to do a large project, and then the engineer of record and the AHJ who are on top of things say, oh, by the way, we're going to do an integrated test. I need your people there for 2 weeks. 2 weeks? What are you talking about? It was in the bid. You're responsible to be part of the integrated test. And it does take time to do that. And there'll be times where you're just standing around, but you need everybody there. So it's coming. It's just taking its time. It's slow.
What year of 101 is that? Do you know what edition?
2 cycles ago. So it was 20.
Okay. So, all right. So it's starting to happen now, right?
Yeah, it's starting to happen now as people are starting to adopt it. But the other one is, do they know that it's in there? You and I've talked about that too, is, we put things into the code, we change things in codes and standards. How does that get out to the engineers, to the AHJs, to the enforcing world, if they don't know it? And it's podcasts like yours that help spread that word that, wow, something's out there. I wasn't aware of that.
Yeah. Check with your, your local codes and, how to, yeah. One thing I've noticed, we're largely, in spec point and all that, we're large in Canada, right? And on the fire alarm side, they, on the suppression side, they're NFPA, but on the fire alarm side, they're ULC, right? And UL provides a lot of that. This is just my opinion, right? I feel like their standards for testing and commissioning are better within ULC, or I don't want to say better, it's just they're structured better for people to adopt and follow through with that. And NFPA is a great document. It's just like, I just noticed that, man, everybody follows ULC pretty much to a T, right? And it's kind of written that way, where NFPA is kind of like, certain states do it this way, certain cities do it this way. And it's more the adoption that I've seen. And you can kind of compare them because it's like, well, NFPA 25 and 13 or whatever is pretty equal across the board for both nations, but then fire alarm is different.
Yeah. Well, and also in Canada, you have a countrywide requirement for certification, that we don't have in the U.S. I mean, some states require a certain level of NICET or some kind of a state license or what have you. But up there, you have to go. And then also something that they do, which we are pretty not as good at in the U.S. or other parts of the world. In Canada, you've got to go and you've got to sit for so many hours to get your recertification. In a lot of cases in the U.S., I mean, you can put in, well, I attended a seminar and you can get so many continuing development points. Yeah, that you've done. But there's nothing that says, Florida, for example, they have the FAST, a fire alarm system agent, where you have to sit for so many hours for your recertification. And somebody's telling you, or you're going through some kind of a class to give you those changes. And I think Canada does a pretty good job at that, where you have some of the Canadian fire alarm associations up there that help to make sure that their technicians understand what's changed, what they need to know.
Yeah, I know you were mentioning that, Canada's kind of on top of things, at least on the fire alarm. And again, I think once NFPA 4 comes around a little bit more within the states, that'll help for sure.
Yeah, that should help out a lot more.
One thing you mentioned prior as well is like, CO monitoring, and, that is that pretty new to the standard as well, or is that been in there for a while?
So that's a yes and no answer, if I can do it that way. So for many years, there was a document for carbon monoxide alarms and systems called NFPA 720. And not a lot of people knew that even existed. But so I'll make the long answer longer. So the thought was back then that the people that were going to enforce carbon monoxide detection was not going to be a fire official, but a building official. So we don't want a building official to have to go through all of 72 to figure out carbon monoxide. Let's just give them a small document. It's just focused on CO. Nobody hardly ever used it. Plus, at the time, 72 was limited in its scope where it could not do gas detection. And 72 wasn't going to be, the scope wasn't going to be changed back then. This is prior to 2010. So we had NFPA 720, and I was on that for several cycles. Tom Norton with Norell was the original chair, and Art Black chaired it for a while, and Shane Clary chaired it for a while. So it was around for several years. When 72 did a drastic change of scope in 2010, where they limited what you needed to do for inspections, broadened the scope to allow mass notification. It also added in the allowance to be able to do gas detection and other things. So in 2016, 720 was put to bed. All the information from 720 was then imported into 72, and now you have carbon monoxide requirements embedded in 72. However, it's exactly the same. Where I put them, how many do I need, the temporal for recording, the notification is all there. So all of that's really been the same. They've tweaked a few things here and there. We don't call them bedrooms anymore. We call them sleeping areas, because there was confusion about where you say to put in carbon monoxide in bedrooms. Well, I have an area that's not a bedroom, but people sleep there. Well, there needs to be devices that go there. So they changed the language from bedroom to sleeping room or sleeping area for that. So yes, it is new to 72, but no, it has been in the code for a while now. But CO is nothing new in our world. It's been around since the dawn of time. It's the inefficient or incomplete combustion of fuel or burning of something. And it's whether it's coal, oil, gas, propane, wood, all of those come into play. If you have any of those in your occupancy, you need to have carbon monoxide. And then the building codes have now really enveloped or engrasped the carbon monoxide requirements and put them in pretty much all occupancies today. There's a couple of them that don't need them, storage occupancy, but pretty much everything you need it everywhere if you have a some kind of a fuel burning appliance or fuel or carbon source.
Yeah. I mean, near and dear to my heart, or one of our friends owns a farm kind of banquet area, and they were doing construction over the weekend, and I heard from them that, the fire department was showing up on their site, right? And they didn't know what was going on. And it was a gas fired. They were doing construction, and I don't know what type of tool they were using, but there was somebody doing work down there. It set off the CO alarm, went back to the obviously central station, alerted the fire department. The guy didn't even know, right? He shows up, and then and there you go. It was in the building code. They probably made a change to this old farmhouse and had to put CO in that area and probably saved this guy's life.
Absolutely. Because it is, just a little side note, it's colorless, odorless, tasteless. You don't know that it's in the area. And the effects to the human body is I start to feel I have a neck ache, a backache, my head hurts, my stomach's nauseous. I got a bad case of the flu coming on. I may as well just go take a rest and let it take its course. It might be carbon monoxide poisoning. But then another thing for inspections, so how do I test carbon monoxide? Because carbon monoxide is a sensor that uses time and amounts. So we have different parts per million of CO that's in the atmosphere and how long of time it's there. And the higher the concentration level of CO, the less time that's needed. So time can go from hours to maybe minutes. But if I go in, do I take a large supply of carbon monoxide into a building and then flood that detector with it? And what building owner is going to let me do that? So we have these algorithms in our detectors that UL mandates on. At this concentration, you need to go into alarm at this time, not before it. So there actually is timings that I cannot go into alarm because I want to keep false alarms or nuisance alarms down. So I say all of that because at 400 part per million, it could take you 20 minutes to set a device into alarm. So this is the only device that we have in the market, everybody, not just Johnson Controls, that UL allows me to turn off the algorithms and let it work like a smoke detector does, in that if I see a little bit of CO, go into alarm and the device is tested, functionally tested. When I'm done the test, turn the algorithms back on, and then all the fancy timings are there. So that's how we were able to work with UL and the building codes to get the testing into it. Because originally there was no allowance for that. And the thought was you were going to have a big backpack full of CO and you were going to run around and stand there for 20 minutes injecting these large amounts of carbon monoxide into devices. And we're like, you can't do that. So that changed.
And you don't want the solo poles up there with a can of, they got a bunch of cans of CO on them.
And they do have those too, by the way.
Oh, all right. I didn't know they had CO ones. I know
carbon monoxide generators and carbon monoxide cans. Just like cans of smoke, you have cans of CO.
Yep. Okay. All right. Yeah, I know they have some new technology out there that's trying to do it at a smaller scale and get rid of some of those cans, but see where it goes. Roger, this has been great. I'd love to have you on again at some point soon. I know we're working closer and closer with JCI, and I'd love to. This is great. I learned so much, and kind of selfish for me to have this podcast because I get to have incredible professionals on like yourself to to learn and spread the word, right?
I enjoyed, Drew. Thank you. And thank you for what you do. I've been listening to you for a while and what you do and educating the world. So thank you for what you do too.
This is episode 93 of the Fire Protection Podcast powered by InspectPoint. I want to thank Dr. Roger Reiswig coming on the podcast today from Johnson Controls. And yeah, it was really cool to learn about some of the evolution of our fire alarm codes and all that. And yeah, it was great to have him on. And again, I'll see him at NFPA, maybe do a little clip with him there. And yeah, looking forward to it. Thanks for listening and see you again soon.